This presentation will be going over what an accelerometer is, how it calculates acceleration, and its societal impact. An accelerometer is a device used to measure the acceleration or vibration of a reference frame, usually the device they are installed in. There are many different types of accelerometers used for various purposes. One type of accelerometer is the MEMS, or micro-electro-mechanical accelerometer, as shown in Figure 1, which calculates acceleration by measuring the capacitance of a capacitor plate, and capacitance being how much electricity a capacitor can store, and a capacitor plate is a device used for storing electrical charges. The capacitance is inversely proportional to the displacement of the mass as it experiences forces acting on it. Focusing on mechanical accelerometers, they use springs and an alternative mode for displaying acceleration. One commonly known example of a mechanical accelerometer is the seismograph used for measuring the magnitude of an earthquake, as shown in Figure 2. A seismograph uses a heavy mass attached to a spring and a needle to write on a roll of paper. As a reference frame, the Earth in this instance experiences a force. The mass will move from its resting position and draw on the paper, indicating how much it has been displaced, giving us a value for x. With the mass predetermined and the k constant already known, one can use Hooke's law and Newton's second law to calculate the acceleration at a given moment. Let Fnet equal to mass times acceleration, and also equal to elastic force minus gravitational force, where the elastic force is equal to the k constant multiplied by the x, or the displacement, and the gravitational force is equal to mass times gravitational acceleration. You can get the equation: elastic force minus gravitational force is equal to mass times acceleration. Substituting and rearranging the equation to find acceleration, the equation becomes acceleration is equal to the k constant multiplied by x, the displacement, minus mass times gravitational acceleration over the mass, as shown in Figure 2. Accelerometers have benefited society in many positive ways. Taking the seismograph for example, it has helped us predict and prepare for earthquakes that could be devastating. Another way accelerometers have benefited society is in a car and when to deploy airbags. The accelerometer would detect a sudden change in acceleration, and if it was over a certain threshold, it would deploy the airbags, ultimately reducing the amount of car crash related deaths as shown in Figure 4. This concludes my presentation.